Hi everyone, my name is Bhavani, Department of Physics and Electronics from K.B.N College. Now we are going to discuss about sequential digital circuits. Let's see in detail. So what is meant by sequential digital circuits? As sequential digital circuits are a type of digital circuits that employs memory elements to store and manipulate information. Unlike combination circuits which produce outputs slowly based on their current inputs, but in sequential circuits that depends upon the past inputs as well as present outputs. So here we have two types of sequential digital circuits. One is synchronous and another one is asynchronous. To design sequential digital circuit, we have some type of components such as flip-flops, logic gates, multiplexers and decoders, etc. These are the different types of components we use to build sequential digital circuits. In modern days, sequential digital circuits are used in any ways. So example, digital systems enabling memory feedbacks and sequential operations, decision making, so like that. So next let's see in detailed. So these are the concepts today we have to discuss. One is flip-flops and other one is resistors and counters. Let's see in detail. So flip-flops. A flip-flop is a fundamental building block of digital circuits that is used to store and manipulate binary information. It is a type of sequential logic circuit that retains its output state based on the current input and clock signals. So in flip-flops, output will be based on the current input as well as clock signals. So most of the cases flip-flops are very used in example memory elements and data storage and synchronization. This type of sectors we have to use flip-flops. So in flip-flops we have two types of stable states. One is set and another one is reset. So here we can see the different types of flip-flops. Now we have to discuss one by one in detail. Let's see SR flip-flop. SR means state, set and reset. Set means condition will be high and reset means condition will be low. So the SR flip-flop is a asynchronous sequential circuit. Okay. So it have a clock signal also. Here the example for SR signal, the logic diagram will be made up of using NAND gates. So here we see the truth table. We take the different conditions. If both one condition is high and one condition is low, the Q means output and Q bar means complement of the output. So if S becomes 1 and R becomes 0, the state will be set to 1. It means high condition. If both conditions are high as in input, the output will no changes. If R condition will be high and S condition will be low, then the output becomes 1. So if both conditions high, there is no change as we saw in before. So if both conditions are low, the output will be invalid. This is the truth table for SR logic flip-flop. Next the JK flip-flop. So it is another type of flip-flop while using in digital circuits. It have two states, that is J means set and K means reset, as well as clock input also, and it have two output states. One is normal output, it means Q, and another one is complement of the output. The JK flip-flop will be more flexible when compared to other flip-flops. So JK flip-flops are widely used in digital systems for various purposes, including memory units, counters, and shift registers, complex sequential circuits, etc. So most of the cases we are going to use JK flip-flop only. And JK flip-flop have a clock signal. It means it will be edge triggered. Edge triggered means either rising edge or falling edge. Rising means the edge will be the clock signal will be high, it means positive cycle. In falling edge means it will be negative cycle. This is the about to JK flip flop. Here also we checking NAND gates to build the JK flip flop circuit. Next the T flip flop. Okay, it is also known as toggle flip flop, is another type of flip flop used in digital circuits. In T flip flop it have only single input and two outputs. Output means normal output as well as complement of output. Before T flip flop we saw in two types of flip flops. There it have two inputs. So but in T flip flop we have only single input only. So T flip flop most of the cases used it in for creating the frequency dividers. It means clock signal, it generates the clock frequency. So most of the cases it generates the square wave, and it uses to binary counters as well as feedback loops, etc. So the condition here we can see the truth table. If input will be 0, output there is no change. If one input is high, output becomes low. It means opposite condition. If input is high, output will be high and complement of the output will be low. This is the truth table. Here we taking the NAND gates for example for T flip flops. Next see the D flip flop. It is another type of flip flop while using in digital circuits for storing and synchronizing the data. D flip flop means data flip flop. So here we can store the data and synchronize the data with using clock frequencies also. Widely used in sequential circuits. For register means it stores the data and it stores the information and programming, and different kinds of memory locations are there in registers, and as well as shift registers also. This is the, it provides the straightforward. In T flip flop it provides the square wave, but here D flip flop provides the straightforward way to store and synchronize data based on the clock signals. Okay, this is the block diagram and this is the truth table for D flip flop. Next see the master slave flip flop. It is very important flip flop in digital electronics. Okay, before already we saw different kinds of flip flops. In that time we use only single flip flop only, so there is no combination of flip flops. So for one flip flop we use different types of gates, but here master slave flip flop means combination of two separate flip flops known as master and slave. So master means it controls the overall the process. Slave means it acts as a input as well as output. Slave under the master. So the main controller in this flip flop master. So to provide enhanced functionality and synchronization, the master slave configuration helps to eliminate potential race conditions and ensure proper timing in sequential circuits. It provides the proper timing for different kinds of situations. It has two stages. One is master and another one is slave. So it have two different or same flip flops we are using. So master flip flops are widely used in digital systems and sequential circuits where proper timing and synchronization are critical. So when compared to other flip flops, master slave is very useful because nowadays timing and synchronization and combination enhanced enabling the data will be difficult when compared to other systems. So in that type of situation we go for master slave flip flops. They help to ensure reliable and predictable operations. It means critical to the position will be critical to normal, so very useful to user also. Here it generates the clock frequency, clock pulse. It means rising edge as well as falling edge. Rising edge means high and falling edge means low. So here we take the different kinds of states, and the output will be, sometimes it will be low hold and sometimes it will be reset, and sometimes it will be set and sometimes it will be toggle. This is the master slave flip-flops. These are the different types of flip-flops while using in digital electronics. Now let's see another concept, registers. Already we know that registers are very important role in our daily life. It means it stores the data as well as programming, whatever you want. It's like a memory, so you can store any data, any kind of data in registers. Now let's see in detail. In digital electronics, a registers refers to a group of flip-flops or storage elements that are used to store. Already we know the store means it will be store the some data and manipulate binary data. Binary means it comes under zeros and ones. Okay, digital electronics is nothing but all about binary number systems only. It is a type of sequential logic circuits commonly employed in various applications including data storage, data transfer and data processing. A register is capable of storing multiple bits of data simulations and typically organized in parallel. It stores some purpose. Most of the cases data registers are used, registers and data transfer and control logic. These are the three concepts while registers are using. Let's see. So already we saw what is meant by registers. In register we have two types. It means serial and parallel. So SISO means a serial in and parallel out, serial out. So this is a type of register in digital electronics that allows data to be seriously inputted and outputted one bit at a time. It is a sequential logic circuit that stores and shifts data through its internal storage elements. A serial in and serial out register consists of a chain of flip-flops connected in series. Here we use number of flip-flops for data transferring, with each flip-flop storing a bit of data. The input data is fed into the first flip-flop and subsequently the data is shifted from one flip-flop to another in serial manner only. So while using a serial combination of flip-flops, the data will be transferred in bit by bit from one flip-flop to another flip-flop. Overall the cycle. So most of the cases SIS were used in data communications and serial data transmission, data storage, etc. This type of applications are comes under SISO. Let's see another register. It means parallel in and parallel out. So the data will be transferred bit by bit in parallel condition. Before that the data will be transferred bit by bit in serial combination. Here the data will be transferred in parallel conditions. So okay, the parallel in parallel register consists of a group of flip-flops which each flip-flop storing bit by bit. Same process will be repeated here only, but the circuit connection will be different. It means parallel combination. So parallel registers are often used to combination of other digital circuits and components to build complex systems including microprocessors. Very important key role for microprocessors and memory units and data buses. These are the different kinds of applications while using parallel in and parallel out registers. Okay, next let's see counters. The main concept in sequential circuits, one is flip-flops and another one is registers and third part is counters, the most important concept. So counter, what is meant by counter? Let's see. In digital electronics, a counter is a sequential circuit that generates a sequence of binary numbers in a specific order. Counters comes from timers, so it is commonly used to count events, track the progress of process, or provide timing signals within digital system. Okay. Counters can be classified into two main types. One is asynchronous, it also known as ripple counters, and another one is synchronous counters. So these are the two kinds of counters. One is synchronous, another one is asynchronous. Oh, let's see. So asynchronous counters means asynchronous counters use flip-flops to connect in a cascading fashion where the output of the one flip-flop serves as a clock input for the next flip-flops. So asynchronous means here it don't have any clock frequency, clock pulses. So for that type in digital systems we have to prove clock frequency also though. So sometimes some conditions, some applications are use clock frequency, some applications are based on not based on clock frequency. In asynchronous there is no clock frequency, but in synchronous we have the clock frequency. It means crystal oscillator will be there. So sometimes asynchronous we have to install the crystal oscillator modulator to generate the frequency. So last in last out and first in first bit. So these are the different kinds of data will be transferred one place to another place, or one flip flop to another flip flop using so the data will be transferred bit by bit or parallel or series, whatever it may be. The counter will use to count the number of cycles or number of events or number of applications will be processed and progressed. So this is the main functionality of the counters. So asynchronous counters have some advantage to simplicity and case of implementation, but are prone and delays due to the triple factors. So sometimes it will be counting will be delayed some microseconds or milliseconds, whatever it is. So some delay will be there by using the asynchronous counters. Next synchronous counters. So synchronous counters are common clock signal that is fed to all the flip-flops within the counter. Already I told asynchronous counters there is no flip-flop, there is no clock signals internally. But while using the synchronous counters there is the clock signal internally. It means they have a crystal oscillator application or module internally. So while by using synchronous counters by default it generates the clock frequency. So it counts the bits or data with using synchronous combination. It syncs the data. So these are the different types of clock counters. Next, so already we know the counters will be separated in asynchronous and synchronous. So now let's see mode 8, mode 10 and mode 16 and 4-bit ring counters. So mode 8 and mode 10 are comes under asynchronous count, examples of asynchronous counters, and mode 16 will be comes under synchronous. It means it syncs the clock signals and ring bit counter. Now let's see in detail. So mode 8 asynchronous counters. So are specific type of asynchronous counters that can be count up to 8 distinct states before rising. We know 8-bit means it has 0 to 7 values. They are designed to operate with the 3 flip-flops. It means we using the 3 flip-flops to generate 8-bit mode asynchronous counters. 0 to 7 means binary representation. Counters also known as 3 flip-flops connected to cascading fashion. So commonly used in different types of applications. They find application in frequency divisions and event sequencing and control logic. Additionally, and mode 8 counters can be combined with the other counters or logic circuits to create more complex counters with larger counting range. So mode 8 asynchronous bit means it counts the 0 to 8 representations in digital electronic system using asynchronous system. Now let's see mode 10. It is another example of asynchronous counters. Here it represents the 0 to 9 numbers. It means decimal numbers. So here we using different kind of 4 flip-flops. In 8 mode we used 3 flip-flops only, but here we used 4 flip-flops to providing counting sequence from 0 to 9. So counters or 4 flip-flops are connected in cascading fashion. So most of the cases it will be used to utilize frequency divisions and event sequencing and control logics and other applications. Different kinds of if we have to count the, we are counting the number of digits or whatever it may be related to number system. They in that kind of situations we go with mod 8 or mod 10 asynchronous counters. Now let's see another synchronous counter. It is 16 bit means hexadecimal. We know that hexadecimal means it have 16 digits. Okay, 0 to 15, it counts the 0 to 15. Here also we used a 4 flip-flops for providing the counting sequence from 0 to 15 in a decimal representation. Okay, it's a synchronous counting, and it means it have the clock frequency internally. So precise timing means it counters offers the precise timing. Precise means exact values it will be provided, and synchronized outputs due to their shared clock signals. They're commonly used in various applications where counting sequence up to 16 states is required, such as frequency divisions, event sequencing, control logic, and digital arithmetic operations. So these are the different types of examples of counters. Now let's see a 4-bit ring counter. It is another type of synchronous counter. It's a special counter. So the 4-bit ring counter, the output of each flip-flop is connected to the next flip-flop in the sequence, forming a crucial or a ring-like a structure. So the output of the last flip-flop is fed back to the input. It means it will be, it rotates like a ring. So one flip-flop output will be act as another flip-flop of input. So creating the continuous loop. It will be repeated unless we stop the loop. The 4-bit ring counter find applications in areas where the specific counting sequence or pattern is required, such as frequency divisions, waveform generations, or sequence generators in digital circuits. So it's important to note that while the 4-bit ring counter provides the distinct sequence, it does not cover all possible states, as it loops through subset of the total 16 possible states of the 4-bit counter. This is another type of counter. So these are the different types of counters and registers and flip-flops in sequential circuits. This is very important topic in digital electronic systems. So these are the basic concepts while learning in digital electronic systems. Thank you so much for giving this opportunity, and thank you.